And welcome back. So this is Extremely Open Science, and we are today going to be doing an hour of science streaming, basically me working on our project called Sardine. And I'm sharing the wrong screen. I wanted to start by sharing this one. So we're working on Sardine, picking up where we left off. A couple of weeks ago we had a break because of the cyclone, which fortunately by the time it reached the city was an ex-cyclone, that being the technical term actually. But I don't want to minimize it too much. It did really batter the coastal regions, especially areas like the Gold Coast and people and in the islands off the coast of Brisbane, and the people who live there were really very heavily affected. But here in the city, we're a little bit far away from the coast. It's about 75 kilometers. I don't know how much that is in American, let's say 50 miles from the coast. So by the time it reached us, it had sort of lost a lot of power and strength. All right. So with that said, let's go back to now. We will go to the code. So this is the Sardine project. Let me just check where we are. So this is the what we did last time, where we were discussing the possibility of moving from working with KOs that we were getting from the. Sorry, there's a camera there. I switched cameras. I'm still not happy. With the streaming setup. I don't know, because with the other camera it's very, very crisp on my screen, but then when it streams it gets a little bit fuzzy, and now I have a slightly different camera setup. Not sure if it's that much better, to be honest. I'm not sure what exactly. I'm now using my phone as a phone. Anyway, let's see if this is a little bit better. All right, let's get down to it. So this is what we were trying to do. I can't spell. What we were trying to do last time was, we take a switch to using Eggnog Mapper instead of KOs. Using the KOs would have the advantage that we could very easily plug into CheckM2. But if it's not the best, it's not the best. I mean, those types of practical advantages can be a tie break. If it was all the same, that would be an important tie break. But we will try, and if using Eggnog Mapper is better, then we will go with that. So we had done this. I'm just gonna run this again, and then this and where we put that to the side for a second, taken this one random file, all of these protein files, and then gotten all of the sequences. So we get all the sequences. Let's do a little bit longer than this. That's good. Okay. Let's just check just double check that there are no repeats. Yep. And we had installed Eggnog Mapper, right? And so we've been, this was also something that we did a couple weeks ago, which is we switched to using Pixie. So we have, in principle, we have Pixie shell there you go. So we did download it to this data there. So let's see. Let's me. Let's just look up the arguments. No, this is not what I want. Yes, this is what I want. I've written code to run this a million times. So well, at least 17. Okay, making progress. It's a bit annoying. Okay, sorry. All right. So running Diamond. Okay, this seems making some progress. CPU, what I want? I want to. The number of threads. I type proteins. I think this one I'm gonna looking through the list of arguments. I think this might be it actually. Right, so we're programming in dark now. The dark now. Right. Welcome to. All right, so let's go back to the main. Doing a little bit of cleanup as a positions. Okay, so instead of doing this, so we still run check M2. And then we had, yeah, let's do this. Oh. So this code we had written last week. So this code we had written last week. Now we're just going to move it from this random file where we had left it just to save it into and integrate it with the rest. Then we're gonna do this. Okay, this will work. I think this will work. This is what's, yeah, okay, so diamond's still running, right? But so today I would be pretty happy if we can get as far as to write the code that runs the eggnog mapper. If we get to that, we'll be good. We can do everything else next. Then I'll run a lot of it over the week, and then next week we can look at some of those results. Let's see. I could also save the full header. everything's a bit slow because I'm running the diamond on the other thread. Yeah, we could, let's do this actually. Actually, let's do this a bit different. Okay, the reason being that, okay, now if I keep the full header, then we had all of this thing about parsing the headers, right? Get all gene positions. Right, we don't need this if, or we don't need to go back to, we don't need to go back there. If, so this, let's sort this. Not even sure it matters, to be honest. Maybe just for the, yeah, I'm not sure it matters. Sorting things isn't, there's one big advantage is that it makes them, you know, if the FASTA file is the order doesn't matter, but by sorting, now we made it be deterministic. So if we run it a couple of times, it will always have the same results. Sequences. Okay, this will work. Problem here is that actually nothing. This works actually quite well, but now, so normally the big advantage of, or one of the big advantages of using Jug is that we can reuse partial results from, so in this case, you know, we have already run the checkm2 stuff, and so we could just reuse those results to keep going. Unfortunately, and this is a big unfortunately, we had then done this get all positions step, which would destroy the previous results, and now, yeah, so that's not great, which means that now we need to rerun this step, the run checkm2 in general. So that's going to be pretty oops, sorry. So here I'm gonna so that's, yeah, so normally that's not the best use of Jug to have these destructive operations, but in this case, I mean, there's also some practical things. So let's So we can, let's invalidate those, meaning I'm going to tell Jug that effectively we need to run them again. Also, we invalidated the get gene positions, which I don't want to. I want to. This might be a while. Yeah. No, that's a. Did I write CPU? It is fine. I don't know what override. What does over? Oh, maybe override. No, file comments are good. Yeah, it seems good. So we've been spelling it out here. This is out there. Okay, this should work. Big problem here is that this is now gonna take for a long time. And so I'm not sure what's the I'm not sure that what's the best use of our times now. By the way, completely unrelated, but I am looking for PhD students, so if spending a lot of time fighting with Eggnog Mapper is the sort of thing that appeals to you, gonna do that for a few years, then do get in touch. I mean, this is not the point. Is obviously not to fight with Eggnog Mapper, but but trying to solve these issues, working through technical issues with the goal of contributing new biological knowledge. That's more maybe that's more the spirit. Okay, so let me see. I'm gonna just pick one random one, see what's going on here. Yeah. Okay. Problem here. Oh, okay. This might be a good sign. So Diamond is now only using 200 CPU. Well, okay, spoke too soon. Sometimes when programs are finishing, they drop some of the CPUs that they were using before. Okay, so this one, let me kill this one. It's probably not going to finish. Okay, now it's running checkm2. Right. Okay, so this is what we've been doing so far, many times. Nothing new here. Then bit of a shame. There it is, running checkm2, calling prodigal a bunch of times. And actually, in fact, this is the only thing we would want. I'm not sure how to. I'm not 100% sure how to proceed here right now. Oh, sorry. Okay. No, not that. Got it. I'm gonna keep that there for now. Yeah. Okay, so I forgot to add the recap there. Nope. Not yet, but says or let's just let's do that as well. So this combines sequences, what do we want here? Actually, let's just keep everything. Just keep everything. So I'm gonna commit, switch to main, and then just merge the work in progress. Okay. Did I mess this up? Yeah, okay. Yeah, I guess all of this... No, it wasn't. All of this was work in progress. All this is work in progress, and this should actually just work, the code we wrote. The only thing that really... Let's... get all gene positions. Okay. It is 5. This is not the one that's running, right? Is it? Jesus. Oh, it is. No. Sorry, I'm... Okay, actually, since we're here, let's turn this into a frozen set. Just okay. I created this. Also, I created this file __ jug. Please stop running.txt. So what this does is simply, asks Jug to please stop running. So it will keep going with the current task, so it does not interrupt it. So it's not the same as, Control C, but once it's done with that task, it will then stop. It will not keep going to the next task, and it will finish in a nice way. All right. So in the meanwhile, we want to adapt this. So we had get all gene positions. Sequences. So this is going to receive this sequence. Okay. You got gene positions. All right. And then this is no longer an F, but a header list. Actually just work. Okay, this might actually just work. Should really put this cleanup code somewhere, because we really should clean up. Anyway, be a bit mindful of time. Oh, we still have plenty of time. I'd finish a bit early today. I mean, normally I try to do an hour, not go too much overboard, but today we need to wait for some of this to run. It's always, and I never really account for these things properly, but you can see in my top that, so you have OBS, that's the streaming tool there. Let me do this again. that's taking a lot of my CPU. So the prodigal processes, are a little bit so everything struggles a little bit. Everything's just slower when I'm streaming anyway. Probably shouldn't be doing all of this at the same time. Let's see if YouTube's not complaining. Sometimes it complains, but today is okay. But still, nonetheless. Okay, this is much. It's nicer. Okay, I am going to let's just add a little bit. Exist. Yeah, so it's sort of this run after. I've played with adding this more explicitly run after business to jug. I never got around to it. Oh well, I've done it, but I've never really nailed it down. But the idea is that once we have let's do this. So a lot of this is defensive coding. A lot of this is defensive coding because right now I've added a bunch of checks, make sure that nothing really, that I'm not, especially here, if I'm going to be deleting things, I'd be sure I'm not deleting, like, it would be stupid to, have gone to all of this trouble to create the one file that has the dereplicated, and then just because of a silly glob typo would then delete everything, right? So now I think this works. Everything now works. I think everything now works. Everything. Just check the time. Okay, well, let's finish a bit earlier maybe. Okay, I'm gonna so add some defensive coding here a little bit, and then integrate gene. Okay, now everything should work. Everything should work now. I will run this over. I will run this over the week. Especially try leaving it running when I'm not here overnight. I might slightly. We've talked a little bit about how, you know, so this. Right, so this is. So we're doing 1 every 200th genome. We can, so which means brings us to 209 genomes, but we can increase this to 1 every. Oh, actually, I thought 200. I thought these were pre-computed actually. Oh well, maybe not with the. Oh, maybe not. Yeah, but maybe I do want to. I'm gonna kill this. So I'm gonna run a cleanup operation. Okay. So what cleanup does is there might have been things like from the past that I didn't want to have to deal with again. Yeah. So just in the interest of actually having something that finishes, let's do 1 every 800th. So if I remember correctly, this will be about 43 of them. So this will be much more manageable. We'll probably have results by Wednesday or Thursday, rather than having to wait too long. So we'll probably have some results quickly, and then okay, I'm adding. So I added this linting, which I'm not. Some of the things I agree with. Some of the things I find this idea of, you know, especially in Python where you're indenting the beginning of the line anyway. This idea that we should use that it's bad to have more than 80 characters is a little bit silly. But okay. Okay. okay, this will be it. A little bit, maybe I guess a little bit, maybe a little bit less. A little bit less productive today than usual, but let's just push. Just push. So we just pushed everything to the, just pushed everything. So, and then let's see, check status. I'm just gonna, yep. So this would be because this, gonna, yes. Okay, I'm gonna leave this running. It's gonna take a while. Oh, forgot. Leave this running. It's gonna take a while. I'll just leave this running out here. So I did push everything to the GitHub, so everything's on GitHub. Oh, where's me? I'm not here. I'm not here. Oh, did I? Oop. I'm not here. Oh, let me put myself there. Okay, there I am. All right, so okay, and now I'm also facing up. Yep, so I'm gonna leave this running. Everything's on GitHub. Where's GitHub? There? Yeah, there. Everything's on GitHub. There's a mailing list. I'm gonna, whoops, sorry. I shouldn't be doing this live. There's a mailing list. Do subscribe to the channel. I'm posting a couple more things to the channel. There's at least one video scheduled for later today. We'll post obviously the recap video later in the week, especially once we have some of these results, just to show that everything worked. Yeah, looking for PhD students, so just email me if you're interested in how we can use fancy computer methods and AI, or just simple computer methods like we've been using now, to figure out more about biology. Just do get in touch, or if if maybe it doesn't apply to you personally but it applies to someone else, feel free to point them to me. And in the meanwhile,